we're going to work on the notes for lesson 1.1. So lesson 1.1 is all about introduction to practice of statistics. This lesson is just filled with a lot of definitions that are going to be very important for the rest of the semester in your understanding of the material. So we're going to spend some time going over them. And we'll be covering them over and over throughout the semester, so don't worry. But it would be good if you have some sticky notes like these that you could mark the pages. So statistics is the science of collecting, organizing, analyzing, summarizing, and analyzing information to draw conclusions or answer questions. So statistics, sometimes I think of it as you could collect statistics, which means they're things, right? So they could be nouns. People say they do statistics, which would be more of a verb. In some ways that they could use statistics as an adjective too. So all sorts of parts of speech. There's two types of statistics that we're going to work with this semester. One is called descriptive statistics. It's methods used to organize, summarize, and describe data, including graphs, tables, numerical summaries. Inferential statistics is methods used to take results from samples to make generalizations to the population. Okay, so we're going to take from a sample to make a generalization to the population. Chapters 2 through 4 are going to be about descriptive statistics. Chapters 5 through 8 and 9, chapters 9 through 10 are going to be all about inferential statistics. And then chapters 5 through 8 are about measuring reliability using probability. So there are two ways that we could gather statistics as far as groups. One would be the population. A population is a collection of all elements, persons, or objects, subjects of interest in a particular study. So if we were talking about all citizens of the United States, an individual would be a person or object that is a member of the population being studied. And a sample is a subset of the population. So sample is subset and population is all. Okay, so in general, our course we will assume most samples are good representations of the population, called unbiased samples. We're going to assume that. Hopefully that is true. So page 26, it says, we have a recent survey of a random group of JC students asked the question, which superpower would you prefer to have for yourself? Flight, invisibility, super speed, or super strength? The results are shown below. So it says how many students were in this sample. So you can see we have 4 columns and each column has 5 rows. So there are 20 students in the sample. What is the population for the study? So it was a sample of JC students. So we're going to say all JC students. The word all is the key here. And this would be a single JC student. It says make a table of the results from our information given above. So there are 4 different superpowers that they could choose from. And they can be listed in no particular order. I'm going to start with flight, invisibility, super speed, and strength. So if we go through and we count all the flights, there's 1, 2, 3, 4, 5, 6, 7. Invisibility, there's 1, 2, 3, 4, 5, 6. There are 5 super speeds and 2 strengths. And if you want to figure out how many, if you know you had them all, you could add these up. So 7 plus 6 is 13, plus 5 is 18, so there's 20. So that validates that we used everybody in the sample. Which superpower is most frequently chosen? and that would be flight. That's called the mode. What percentage of students want super speed? So a percentage would be x out of n. X is the number that had super speed, which is 5, divided by the total n, which is 20, because our sample size is 20. And that comes out to be 0.25 or 25%. Those are going to be the 3 ways that we're going to show a probability later in chapter 5, or a percentage as 25%. Inferential statistics. What is a generalization we can make from these data? So we could say approximately 25% of JACE, and if we're going to say a generalization, we'll say of all, because we're approximating to the whole population, of all JC students would choose super speed, super speed as their superpower, super strength. We're going to call that their superpower. And you can also say, you could look at any of these as a percentage. So it says, suppose we find out that the random JC students were all calculus students. What effect does this have on our generalization? So maybe calculus students all have similar preferences on choice of superpower. So we probably should have tried to get a better random sample of all different sorts of math students. So this leads us to what we just calculated as far as the 25% that wanted to have their superpower be the super speed. That's called a statistic because it was based on a sample. So notice that these both have S as their first letter, okay? So an average age of sample statistics students, proportion of a sample of statistics students that prefer early morning classes, okay? A parameter is a descriptive measure of a population. So if we knew what every single JC student preferred as their superpower, we could say that that's called a parameter. So notice that they each have the same first letter P. So if you want to kind of put the whole big structure of statistics in the process of statistics together, you're going to first start at some kind of a goal. What is your statistical study design? What do you want to learn about some kind of a population? So you have to decide then what population would be referencing back to what you want to study or what you want to learn. From that population, you're going to draw some kind of a sample, hopefully a random sample. Then from that random sample, you're going to collect some data, and we're going to call that data that you collect sample statistics, okay? And from those sample statistics, you're going to make some kind of an inference about the population of all JC students, if that's what we were talking about. And then you're going to use those population parameters that you've just now estimated to talk about the population. So again, the population, or the parameter, describes the population, and a statistic is a subset of the population, and it describes a sample, okay? The statistic we usually know because we actually have data, which is our sample, but the value of the parameter is usually unknown, right? It's usually unknown because we don't know information about everyone in our population. So down here under this note, it says variability is very important. Without it, there would be no point to statistics at all, because all of the values would be the same. But that's not true. In fact, we will study variability in 2 main ways this semester, from observation to observation within a single sample, and also from sample to sample within a population. So we're going to look at our first big example here. And you're going to notice this semester that we will have topics that we're going to learn, and then we're going to apply them to bigger examples to kind of put it all together. And you're going to see some of similar questions kind of wrap around into future lessons as well, into future examples. So this example is a drug manufacturer is interested in the proportion of persons who have hypertension, which is elevated blood pressure, whose common condition can be controlled by a new drug the company has developed. A study involving 5,000 individuals. So a study kind of lets me know that we don't know something about all individuals with high blood pressure. We just know something about a study. So this is going to be our sample. These 5,000 individuals in the sample with hypertension is conducted, and it is found that 4,000 of the individuals are able to control their hypertension with the drug. Identify the research objective. So we want to know what proportion of the population can control hypertension with the new drug. Okay, that's our goal. And because we can't ethically, right, give a new medication to every single person with hypertension in the whole US, because what if there is a bad side effect? We can't do that in working in pharmaceuticals. So we're going to use a sample. So it says state the sample. So the sample is the individuals in the study, and that sample size is 5,000. State the population for this study, and that would be all people with hypertension. State an individual in the study, and that is just going to be a single person with hypertension. Use the given information to find the statistic. So what's something that we know? A statistic is something that we know about the sample. Well, we know from the sample 4,000 out of 5,000, right? X out of N is 4/5, which is 80% of sample can control hypertension with new drug. That sounds pretty promising from the information we know, 80%. Describe the parameter. So the parameter would be if we knew this percentage for the entire population. So the percentage of all people with hypertension who can control it with new drug. And do we know this value of the parameter? No. And that's because, explain, we only have a sample. And we're hoping that our sample is good, and that our sample is reliable, and that our sample can tell us something about the population. Explain in the context of the situation why the point of the study is most likely inferential. Because we are trying to, use data from the sample to tell us about the population. We hope. We hope, we hope. Okay, so this statistic that we use here, the percentage of the sample that can control their hypertension, is one way we are going to come up with statistics for data this semester. And this is because this type of data is called qualitative. It's a yes or no question. Were they able to control their hypertension or not? They didn't measure anything. So we're going to look at that here on the next page. On page 29 here, it introduces us to the two types of data variables that we're going to collect and talk about that are out there in the world. And you filled out the survey for our class, and some of the questions that you answered were qualitative questions, right? We asked you your eye color. We asked you what state you were born in, right? Those are qualitative variables. They're categorical variables. They classify individuals in the study or experiment based on some attribute or characteristics. So we can't do any calculations with those, i.e. your eye color or your hair color or what state you were born in. Now, quantitative variables classify individuals in the study experiment based on values that are on a quantitative scale. Meaningful calculations can be done with these variables. Quantitative. Okay, so there's two types of quantitative variables. One is a discrete variable and one is a continuous. A discrete variable is a quantitative variable that has either a finite or a limited number of possible values or a countable number of possible values, okay? Usually there are no decimal places, as in you have to have a whole person or a whole car or a whole animal. Continuous variables are quantitative variables that have either an infinite number of possible values that are not countable. They are usually measured and sometimes have decimal places, such as height or time or weight or length. Suppose you want to gather the following information from a patient. Determine whether the following variables are qualitative L or quantitative discrete D or quantitative C, continuous. So I'm going to let you take just a minute to complete those before I give them away. Pause the video and work on that and then come back. So the answers that I have are L, name is a qualitative, patient number is a qualitative. Have you had the flu vaccine in last year? That's a yes or no, that's qualitative. And service rating, poor, fair, etc., that is also qualitative. Now for the ones that are quantitative discrete, the year you were born, not how old are you, but the year you were born is a discrete variable. Shoe size, even though there's half shoe sizes, there is up here where it says there's a finite or limited number of possible values. Shoe sizes are the one that's going to be discrete that has a fraction in there. Probably the only one you're going to run into this semester. Pain level, not a 1.5, not a 2.5, just on a level of 1 to 10. So that's going to be a discrete. And then age, rounded to the nearest year. So if I had to give a whole year of how old I am, that would be a discrete value. The rest of these are all quantitative continuous because there's something measured. Temperature, weight, age, blood pressure, length of your foot, and weight gain. So anything that's calculated, an average, a weight gain or loss, something that's been added or subtracted or averaged over or summed up are always going to be continuous. So the last little bit to our intro to statistics today are levels of measurement. And we're not going to focus too much on these this semester, but they are important to understand. There's sort of a hierarchy here. So the basic level of measurement are nominal values, values of the variable that are name, label, or categorized data, such as the state that you were born in. There's no order to them. Ordinal data has the same properties as nominal data, but can be arranged into a ranked order. Interval data has the same properties as both nominal and ordinal, but they also have some scale on units. That means there's a difference between a 3 and a 4 as far as your pain level, right? Or 19 or 20 as far as your age. Interval data can be negative, so that's something to think about. So temperatures, temps, those would be considered interval data because they can be negative. Ratio values have the same properties as nominal, ordinal, and interval, but cannot have negative values. So I usually start with the question of ratio and then work myself backwards. So I will ask myself a question of, is my value, my variable, is it quantitative? If it's quantitative down here, then I'm going to ask myself if it can be negative. If it cannot be negative, cannot have a negative value, then I automatically know it's ratio. If it can be negative, then I know it goes down to interval. You'll notice here in this table, qualitative data can only be nominal or ordinal. So we're going back to these same variables that we just looked at on the prior page, and now we're deciding if these values are nominal, ordinal, interval, or ratio. So go ahead and take a minute and pause your video and answer these questions, and I'll be right back to give you those answers. Okay, so of the qualitative variables, we have name, patient, these are all nominal, had the flu vaccine, yes or no, and of the ordinal, we have shoe size, and service rating. And pain scale, we're going to say it was a discrete, so we called it, that's going to be interval. Okay, and then year born is also going to be interval. Body temperature will be interval because it can be negative. And age cannot be negative, so we know that that is ratio. Weight gain is also ratio. Weight is ratio, age is ratio. Oh, age rounded to the nearest year, pardon me over here, that needs to be interval. Length of the foot is ratio and blood pressure is ratio. Go ahead and make sure that you have the correct answers there. And that concludes